Hello, everyone. My name is Shiho Hashimoto, and I am Marketing Director at SSH Communications Security. Thank you for joining the webinar titled Digital Transformation, Access Control from Mainframes to Microservices. We will be answering to any questions you might have at the end of the webinar, so please write your questions to the question box that should be visible in your webinar pane. I will also distribute the slide deck that's used today at the end of the webinar using the handout section also in the webinar pane. Without further ado, I will pass the mic now to our speaker today.
Oh, hello everybody, and welcome on my part as well. Before I start, I have to announce that there's a small change of program. Kalle Jääskeläinen, who is the announced speaker in the ads and the handsome fellow in the Twitter ad, was called on to pretty important and customer meeting, so he's away on customer business. So I'm taking over and taking you through this webinar. My name is Rossi Sigber. I'm the Product Marketing Manager here at SSH Communications Security. I've been working with SSH and information security for the last 15 years, so I hope you can enjoy my company for the next 20 or so minutes. So the title for today is Digital Transformation Undercurrents, the Access Control for Mainframes and Microservices. And let's see if I can do that. Okay. So we will take a quick walkthrough of the evolution, or through the evolution of corporate computing from the distant past to today and the future. And we will choose the viewpoint of identity and access, or access control to be short. So the chosen viewpoint, in this context, identity means the identity of users, but also of things, service accounts, and processes that operate within the corporate computing world. That is the implementation of our digital world. By access, in this context, I mean the access to systems, data, and services. These are the services that power the digital transformation that we're living through. The term of digital transformation has been described as a total overall societal effect of digitalization. Underneath this trend and the effect is the layer of technology, the layer of corporate computing. And the history of corporate computing, or the evolution of corporate computing, is a history of constant change. And within that change, there's a couple of axes I want to point out. There is this movement from centralized resource to distributed, the axis of unified single homogeneous platforms to heterogeneous distributed platforms, and the movement from vertical scalability to horizontal scalability. So we've gone from monolith systems like the old mainframe to microservices of today and tomorrow. And we'll start our journey from the digital stone age, of the era of the mainframe. So historically, this time period locates in the late 60s and continues probably all the way to the mid or late 80s. What's really marked in this era is the centralization of computing resources. Computers were rare. They handled pretty simple tasks. They served a relatively limited amount of users or customers, and the access control hence was relatively simple. It was built into the applications themselves, or for the users, and the administrators typically had no access control, or it was access control by physical security. Remote access to computers was relatively rare, and if there was, it was based on dial-ups, and it was largely unprotected. So this continued for a long time, and from this era, we've heard the funny quote that there would probably be like 1 to 6 computers in the entire world, which I think was attributed to somebody at the IBM. So things obviously changed, and things started to change when computing power and the microprocessor became available enough or cheap enough so that we could start building the microcomputer. And the big change here happened around late 80s and onwards. So this was a time before the World Wide Web was born, or about the time it was being born. The microcomputer developed fast from a desktop computer to server-side capabilities. The computing powers doubled every year, and by late 80s or early 90s, we had ourselves a networked world where computers were present in every company and corporation and organization. So computing resources became commonplace. Commercial off-the-shelf servers were everywhere. They were distributed. Computers were in every home, every house, and definitely in every company. There were diverse hardware platforms from different vendors, multiple operating systems, again from different vendors. Technology was very mixed and heterogeneous. The users and the customers still had relatively little access to the actual computing backend, and the mainframe systems were still out there doing their simple tasks. Fast clients, Windows applications, or X11 applications in the Unix world were used as workstations, and the backend handled really low-level data processing. The backend systems were maintained by administrators, but now there was also the capability of remote access. And our company and our main invention of this company was born at this time to secure the remote access. So computers could now be accessed over the network securely, and the identity of the person accessing the computer was securely and reliably authenticated. Also, the access itself was controlled, and access controls to systems started to become more complex. And towards the end of the 90s, the availability of hardware, although it was very much available, hardware itself was becoming a bit of a problem. We had a small company could have up to tens of servers and maybe hundreds of workstations. And maintaining those servers and workstations started to become an issue. Hardware would break down, and they would take on constant maintenance, and the cost of owning computers was going up. The next big shift in this evolution, from my perspective, is the migration towards cloud. So going into the 2000 or 2010, the first versions of kind of cloud platforms were available. So this largely solved the hardware problem. We no longer had large numbers of physical devices to cater for, to manage and maintain. And this migration was really fueled by two inventions. One was the invention and innovation and enhancements in the virtualization technologies. Pretty much anybody. The costs are going down. The cost of hardware is practically zero, and the first migration towards this cloud was called lift and shift. We'd just take the image of the computer we would have as a physical device and lift it to the cloud and shift it to the cloud. The other driving innovation behind, or capability behind this, was the advent of networking. So networking became commonplace. There were fast data networks everywhere, and connectivity in pretty much the entire Western world was sufficient to operate things remotely. The amount of users for the services increased, and the amount of administrations increased because the amount of servers, or the server instances, although they're not virtual, increased probably tenfold or hundredfold. If a small company in the 80s or late 90s might have 10 or 12 servers in the cloud scenario, it would be easily blown up to 100, because again, the hardware would cost almost nothing. Again, the mainframe systems will still there, but isolated in enclaves and doing their own things there. So secure access and remote access to servers and resources became almost every day. Remote access is the norm. The notion of local computing is starting to disappear. We don't think Salesforce as being a local or a cloud service. It's just there. Facebook is everywhere. Google is everywhere. So whether or not a service is run in your organization outside lost the meaning to most users. That's it. Which is a big. I'll explore that in a little bit later. A big mental shift. We were no longer thinking about servers and computers being local or hosted somewhere. We're just thinking about the service. Another interesting development that sort of was born in this sort of cloud migration era, and is really now catching fire or flame or wide acceptance, is the practice of DevOps. So now the earliest, or up until now, the paradigm of development software meant that we would have plans, releases maybe every 6 months, and the team of software developers would be a largest team of software developers would come up with a release with a relatively slow frequency. Now the practice of DevOps turns that around. We will have small teams that come up with really frequent releases very often, and incremental development. So a very different sort of approach, but also meaningful in this context, and we'll explore that a bit later. From access control perspective, this meant that access control was really becoming painfully problematic. How would we enable effective control and predictability into the use of resources, both for customers, developers, and administrators, and not make the access control a constrictor for development or growth? So how to enable effective access control without actually destroying all the benefits we might get from this cloud migration? So the big issues to solve here are scalability, both scalability of the services and scalability of the access control mechanism we employ. So the big change here is that the notion of local and the notion of a host, a computer, is starting to disappear, and it's being substituted by the notion of a service. So the central computing concept of a computer is losing meaning, and the central sort of concept is starting to become a service. We don't really care where the actual computer that runs the Google search engine is located, because we are concerned with how the service works, and we want that service. On the scaling note, there's an interesting pair of observations. So in 1996, Alta Vista, which is then the top search engine of the young World Wide Web, consisted of 5 servers, 5 physical servers. 8 years later, in 2004, Google exercised or did like a research paper on MapReduce. That program that executed that research was run on a cluster of 1,800 machines. So within 8 years, sort of computationally similar problems have really blown up their volume of hosts. And from this, I think we can deduce that it's now 2016. I don't think the number of 1,800 would be anywhere close to market, probably 10 more. So the limits of vertical scalability were reached, and really were reached a long time ago already. There's no way to practically scale things up by adding hosts and adding resources. So there's an inspirational quote I like about this sort of as we go towards the idea of microservices and scaling, and Joshua McKenty mentioned this, that servers in today's data centers are like puppies. They got names, and when they get sick, everything grinds to a halt when you nurse them back to health. On an OpenStack, this is a system for microservices, is a system for managing servers like cattle. Cattle don't have names. You number them when they get sick. You may have to shoot them in the head, but the herd will keep on moving. It takes a family of 3 to care for a puppy, but a few cowboys can drive tens of thousands of cows over great distances, all while drinking whiskey. I don't know about the last part, but maybe Joshua finds it attractive. A pretty more morbid thought about shooting cattle. But so how does what does a herd of computing resources look like? And this, we go to this sort of, I mentioned that it would be like the future of computing, but in effect, it is almost today. These things are being developed, and this is reality as we speak. So we've gone from servers to services, and a big service that could be global, or in many cases is, the number of users and customers is blown up. The number of developers in that DevOps scenario has also blown up, although the teams doing individual components of that service might be really small. The administrators are still there. The whole microservice architecture does require the physical layer that handles the orchestration of microservices and the persistent data storage, databases, and that kind of thing. But the actual customer-facing service consists of very large volumes of stateless, simple services that can be scaled with zero cost almost indefinitely. So this is the migration from the monolithic host or mainframe to the idea of a service. Now, when we need to scale this service, we don't add another container framework. We add the services. We keep on adding those services as long as the requirements of the customer user base is met. These are transparent, resilient, global, and massively scalable. That's the good part. From an access control perspective, we're looking at a very different kind of problems that we had before. We have access that is highly temporal, meaning just in time. The services come up when they're needed, so the access control for the services, the server container the container framework and developer, all that needs to be temporal. The volumes are huge. We can induce how many people use Netflix per day, and Netflix is an example of this kind of service. We have users, we have system administrator, developers. Users may come up in different hierarchies. They may delegate their roles down. So access control is complex and it includes complex hierarchies. So from an access control perspective, we also need highly scalable solutions that can cater for highly temporal access control decisions on the fly. So if we take a little step back, I mean, all this means. So what I told you is that we've gone from monolithic systems to clusters of servers. We've taken the clusters from the physical world to the virtual, being into the cloud, and we've gone from the concept of running hosts in the cloud into running services. The volumes have exploded from a couple of servers to a couple of tens of thousands of little pieces of microservice, and the need for access control remains and intensifies. So the access control decisions are really made on the basis of what the users and the organization needs. So by knowing what kind of needs there are in the user base today, before we're in this sort of cloud or microservice world, we can reduce that and turn that into a policy that should cater and work for us also in the service world. Let's take a look at a couple of real-world examples from scaling and the effects of digital transformation. So on the left hand, the internet giant, we might guess who that might be, but their analytics platform, so a system that collects login events and detects possible sort of anomalies in there. So only the analytics part of the solution. This has nothing to do with their tens of millions of customers, but the analytics service is run on 40,000 servers, 11,000 of which are physical around the world. That's powerful. That's scaling. So no, I don't think that's going to be the access control. That system might not be your average single sign-on solution. Netflix is my favorite example of this, the digital transformation. So Netflix has gone from a company that operates and develops a monolithic DVD rental service in a traditional software development model and actually ships back the DVDs back and forth to the end customers to fully digital. So by embracing this digital transformation, Netflix freed itself and its business from the constraints of this sort of physical reality. So Netflix operates many tens of thousands of servers, serving their customer base worldwide, offering them the petabytes of digital content they have stored in the cloud. So this is, I think this is like the prime example of how going digital, how to realize the benefits of going fully digital. So before I go through the sort of value proposition or takeaway that I promised to go through, I'll say a couple of words of ourselves. So I work for a company called SSH Communication Security. We do identity and access management solutions for ICT infrastructure. So we've been part of every step I described in this short overview, short evolution of computing. At the moment, we offer visibility, predictability, control, and accountability for corporate computing, be it in the cloud, on-premise, or in the future in the sort of microservice architecture. We've invented the SSH protocol in 1995, and today that's still part of every data center on the planet, and pretty much every platform, and also every cloud orchestration platform. We have extensive experience in large-scale SSH key management. Oops, I said SSH key there, but we've done SSH key management projects for some of the largest enterprises on the planet, and we have extensive developments in the world's banking sector for this. Having said that, I failed by avoiding saying SSH keys, but it is an important access control important access control issue as they come. So the takeaways in the invitation, there were 3 things we promised to cover. One was the evolution of computing, then the importance of effective access control, and then how to turn access control into policy and the policy success. So let's take a brief look at these before we go into your questions. So evolution of computing, evolution and history of change, from monolithic to distributed, from fixed to elastic, from static to temporal, and from vertically scaling with machines to horizontally scaling with bandwidth and service instances. Effective access control is the base of security, and I mean effective. In the picture there's something we can laugh at these kind of things. There's somebody evidently wanted to restrict access on that strong road, but then some things may lead us to believe that that's not fully effective. Sad as it is, we've seen these in corporate world. So employing information security and access control is easy. Doing it with the proper effect is not always that easy. And that's where we can help. And the how to treat and how to go about access control in your environment. Our approach is a process-driven approach that goes from assessment to discovering, then to monitoring of the environment, fixing things that are wrong, and then finally in the stage of management when we actually know what we're managing. This is our process, this we know, and this works, and we will be happy to discuss this at any time. The process of temporal access control we discussed in a lot more detail in our next week's webinar, where we talk about just-in-time, the future of access control. Now it will be hopefully hosted by my esteemed colleague, Kalle Jätkiläinen.
Okay, thank you, Rasa. We would like to take questions at this point, so if you have any, please write into the question box in your webinar pane. Okay, so we seem to have one question. What does DevOps mean for access control? Rasa?
Or a loose framework. Hello? Can you hear me now?
Yep.
Yeah. This is a loose collection of directives. It's a practice of software development that emphasizes rapid, frequent releases with small increments. It is very well suited for this cloud and microservice architecture where rapid prototyping and rapid development or frequent releases are very suitable. So the DevOps challenge to access control is that how to implement sufficient segregation of duties, since we are allowing our developers direct access to the production environment. and how to maintain personal accountability in situations where a large number of developers may have direct access to the production environment, and how to do that effectively without complicating a development process or their tools or their processes, and thus losing some of the sort of the benefits of the rapid release cycle of that development. That answered the question.
Yeah, it looks like yes. I got an answer yes. It looks like we only have one question at this time. So I have now uploaded the slide deck to the handout section. So please feel free to download it. You can just click on the link there in the handouts and you can download it. And as Rasa mentioned, we'll be having another webinar in 2 weeks on November 29th. This will be held by our Vice President of Enterprise Key Management, Kalle Jääskeläinen. Please visit our website, www.ssh.com, in order to register. With that, I'd like to thank everyone for listening to the end. I hope you enjoyed our short talk. Thank you, Rasa, for filling in for Kalle, who had to run away to the customer meeting. And we hope we can share our thoughts again on November 29th with all of you. Thank you, and bye for now.
And thank you also on my behalf.